Hey everyone. Welcome to our session today on threat detection and incident response using cloud-native services. My name is Margot Cronin, and I'm a solutions architect specializing in security and compliance.
Yeah, hello everybody. My name is Armin Schneider. I'm also a specialist solution architect for security and compliance. I'm looking forward to the session today.
So this is our agenda today. Cybersecurity and cyber risk has always been a topic that customers have cared passionately about. And now, with the widest breadth of services and tools in the cloud, there's even more actions a customer can take to mitigate risks in these spaces. So myself, Armin, and other solution architects carry out many assignments in this area, which brought together our session today. So today we're going to be talking about what's different in the cloud, but also what remains the same from what you would have experienced before. And we're going to look at threat detection and incident response in phases: preparation, detection, containment, collection, analysis, and then automation and remediation and post-incident analysis. Actually, what we're going to use today to guide our session is the NIST 800-61 lifecycle. You might be using a different one in your organization. That's fine. What we're trying to do is we're trying to begin with technical capabilities, not beginning with cloud-native services. What are the capabilities and the requirements you're trying to drive with those cloud-native services?
All right, thanks, Margot. So I want to take over the first part and want to talk about what's different in the cloud. And I think the big thing is there is just an additional layer in this whole picture, and this is a control plane, right? And in fact, I mean, this is a paradigm shift in how environments operate and how they exist. There is quite a lot of additional log data which we need to consider in the incident response process. But on the flip side, there's also a much better way or automated way in order to react to incidents. And then finally, there is also a more continuous iteration between the life cycles, which we will show then during the course of the session. In order to start with this, I mean, we wanted to start and look into the AWS global infrastructure first in order to elaborate a little bit more details on what really is different. This stuff might known for some of you. We want to still take a look to it in the context of incident response. And when we start with the global infrastructure, we want to talk about the concept of a region, right? And a region for us is basically a physical location where we cluster data centers, and we call each a group of data center called an availability zone. Each of our region has at least 3 availability zones, and we currently have about 96 availability zones across 30 different regions, right? So why is that important in the incident response process? In the response process, right, we might want to go to a different region in case we need. In the case of something has an incident and something happened, right, we're often seeing that compromised accounts has been used in regions where people are usually not using the regions, right, though they try to hide them in those regions. So it's really important, and we come to that in more detail, to have the region concept in mind. The next thing we want to take a look at is basically the AWS account, right? An AWS account is basically a natural security boundary for billing and security access to your resources, in fact. So within an account, we have resources, right? And this could be databases, virtual machines, higher level services, storage objects, and so on and so forth. And then we have the virtual private cloud, so our network infrastructure, where we have basically subnets and basically replaced the traditional network terminology in the cloud-native functionality, basically also with the scale of the cloud. And then there are a couple of other services in those regions, such as gateways and other kind of functionality. And within an account, right, we can spread across many regions again, right? So it's important an account is by default allowing us to go all of the native regions in a commercial platform. There is one thing, and it's worth mentioning here, which is going across region, and this is the identity and access management. And we will look into that later on why this is important to get control, who is allowed to do what in which kind of region, but also on which kind of resources, especially if you want to go with isolation technologies in a later stage. So while the account concept is our isolation layer, what we're seeing on our customer side, customers are running multiple accounts. And it's basically something we're guiding customers through, because typically we're saying this is a good way of isolating your stuff. And then basically customers are running hundreds and sometimes thousands of accounts. So in order to get that under control, we then started with a service called AWS Organization, which is basically an account management service that enables you to organize and manage accounts across your entire estate. And in order to do that, we have one specific account, which we call the management account. And then we have things like organizational units, and then we have sub-organizational units, and we're having accounts within those organizational units. So this is basically the structure and how you can build it. Still keeping in mind, though, the isolation boundary is still the account. But what we can do in this multi-account structure or in using organizations, we can have a centralized control over identity and access management. And we're having a concept of service control policies, and we will come to that in a later stage, which helps us to control what can happen in certain accounts. So we can really use service control policies later on in order to build forensic environments, even if in your own infrastructure if you want to. And service control policy will limit us on what can happen in those accounts and so on and so forth. There is another item which is not on the slide, but it's also quite important, and we'll look into that in more detail. The logging can also be centralized across all of those accounts. Especially in the case of an incident, you might want to have your logs in all in one place. So that's basically, the global infrastructure elaborating what is different. So what remains the same, right? I mean, quite a lot of the tasks, like the general process for performing incident response, remains the same. So the lifecycle Margot showed is coming from older days, and it's still valid. We will see during the course of the presentation there is more iteration in the cloud, definitely. You still need your subject matter expert, especially when it comes to forensics, right? You need to have the people which have this kind of skill. There is no way you can go without those things. However, there are things like the collection of native logs and endpoint to be captured, which are traditional things you had to do also in the past. This is where the cloud can really help and automate them, right? Capturing the logs from your endpoint, but also making snapshots and restoring stuff and so on and so forth. It's something we're digging deeper in, either in the containment phase, but also in the remediation phase, where the cloud native service tools are helping to use these remaining processes. All right, so let's start with our first part here, and this is basically how cloud native services are related to this cycle, right? And I won't go in all details on what the services are doing. We just want to highlight that there are different services, which we are covering in a later stage, related to different phases of the cycle. And if we start with AWS CloudTrail, where you can capture user activity and API activity, well, this falls into multiple areas already. So obviously detection and analysis is pretty obvious on that, but also in the preparation phase you need to worry about it, because you need to take a look at it, set it up. Then we have things like Amazon GuardDuty, classical threat detection, well, it falls into the detection part. Then we are using AWS Security Hub. This one will basically fall into triage collection, pretty much, but also the analysis phase, right? We're having things like Systems Manager. And Systems Manager comes up in multiple spaces here. In the containment phase, it can definitely help us to orchestrate things during the analysis, especially in the forensic analysis. But it also then comes into place into the remediation and restoration phase at a later stage. So it's basically the service which helps us to automate, especially on instances. Then we have Amazon Detective. This is basically our analysis services, which we will dig in deeper, which is definitely used in containment, but it's also used in analysis. And it might be used, and we're really recommending this, in the post-incident activity, right? You might have already fixed your problems, but you still want to take a look to other stuff around which you might want to capture for further steps in the future. So not wondering why this is coming up in the post-incident activity. And lastly on this slide, it's AWS Config. And AWS Config also can help us to measure the state of our environment, so is it configured properly, but it can also help us to trigger automatic remediation tasks based on this. So that's why it also comes up in detection, but later on also in remediation. So as I said, we will dig deeper in all of this. in order to save a bit time. Let's go with the first phase of the cycle. And in the preparation phase, and I'll make this first one pretty short, right? You have to keep in mind that the majority of the cloud-native services, but also the services you might use from third parties, needs to be configured or at least existing or enabled before, right? Some of them you might want to be able to turn it on later on, but it's really pretty much important to make sure these services are enabled if you want to use it at a later stage. As I said, some of them have an exception, but the majority, keep in mind, they need to be configured, enabled. Depending on the use case, whether you use all of them or not, it's a different question. So the same thing is basically true for the log data, right? And we have quite a lot of additional log data compared to the traditional approach. Don't want to name all of them, right? But you need to keep in mind, depending on the service, you might need to enable the log data. AWS CloudTrail, which tracks the user activity and the API logging, we're enabling it by default for 90 days, but if you want to have the data longer, right, you want to look at for years and even multiple years, right, you need to make sure you have it configured. The same thing is true, for example, for VPC flow logs, which is our net flow data. If you want to have this data available, you need to configure this and need to make sure it is stored somewhere where it's accessible in the case you need it. Another one I just want to mention here, because it's sometimes really overseen very often, load balancer logs. I mean, especially in incident response processes, they are important because they are guide you to the real resources behind the load balancer, right? But they are the entry door. So you really want to make sure you have the load balancer logs and at least store them for a certain amount of time. Not really considered as a security functionality, but it's really important if you have stuff behind load balancers. Also worth mentioning WAF logs. I mean, if you everything on the edge, right, you might want to take a look to those things like CloudFront or WAF logs for that purpose. It all depends on what you're using on our platform, but it's really important to have those logs enabled up front, because if you turn it on after the incident happened, it's not going to help. All right, and lastly here, prepare your forensic environment. And I talked about a bit in the organization structure. So you might have an account environment or an OU, depending on how you want to go, ready for forensic, right? And you might want to really limit what can happen in those accounts, or make sure you use all of our isolation capabilities so you can safely do forensic and investigation in those accounts. As I said, the cloud will really help you with that. But again, you need to be ready and have to have it prepared. It's not saying this needs to run all the time, but you need to have the process in order to get it done, right? Same thing is true for containment, right? If you want to isolate machine on the network and those kind of things, you need to make sure you know how to do it and at which level you want to do it. We'll look into that a bit deeper. The forensics tools, right? Systems manager and things can help you to roll that out, but again, you need to have it ready as a run command or something like this in order to use it. And then the last one, and this is something I really, it's very close to my heart, right? Have your log analysis ready. I mean, we're seeing it way too often that customers had something, right? They want to do a log analysis. They had all the logs configured. They had it for 3 years, 4 years, 5 years in S3, in Glacier, or in a SIEM, right? But they had no idea, no process how to analyze it, right? Make sure you are ready for that analysis. It's not saying you need to have all the stuff running all the time, but have a process to get it up quickly, because otherwise, you can still build it afterwards. It's nothing which you can't do after the fact, but it will cost you a lot of time. And sometimes we've seen customer delays of days, right, before they had something up and running in order to look to their log. This is really something, there's a lot of stuff existing outside on samples, on GitHub and other places where you can grab queries and all those kind of things. Just make sure you have it up and running and ready, no matter which service you use, by the way. Okay. That's about on the preparation phase. We're taking over to detection, and I'll move him back to Margot.
Thanks, Armin. So we've carried out our preparation activities. We've identified our organizational units. We're aware of our AWS environment. We've enabled our logging. Now we need to move and identify how we can do our detection activities, how we can detect those unwanted behaviors, unexpected behaviors, and those incidents. Something that is possibly different in the cloud, or slightly different, is the proliferation of data and the proliferation of logs. But as well as that, there's actually now different layers or different areas of data. This did exist before, but it's become even more granular and powerful in the cloud. So if we examine these different areas, first of all, we're talking about our log data. So as we saw the series of log services, Armin had some of them up earlier on. So there's an awful lot of log data, and we use a service, GuardDuty, which is a threat detection service, which continuously monitors your AWS accounts for unusual behavior or unauthorized activity. But then there's another layer or area of data, which is the configuration of your resources. If you experience an incident in your AWS environments, the configuration state of your resource at that time is incredibly powerful data. So AWS Config is a service which allows you to assess, audit, and evaluate the configuration of your resources at a point in time and over periods of time. And finally, then there's Inspector, which checks for which is an automated vulnerability management service, checking and scanning for software vulnerabilities and unintended network exposure. So these are three distinct areas of data which we need to use to carry out our detection capabilities. Let's look first of all at GuardDuty. To detect unauthorized and unexpected activity in your AWS environment, GuardDuty analyzes data from various sources. This data is unmeasured and unchecked. It is not judged, if you will. It's essentially data from various log sources that you have enabled in the earlier preparation phases. So for example, CloudTrail capturing AWS API activity in your account, or VPC flow logs capturing traffic from your traffic to your network interfaces in your VPCs, or Kubernetes audit logs capturing APIs from users and applications to your Kubernetes cluster. GuardDuty uses this log data to check, detect, and measure anomalies and unwanted behavior related to AWS resource types like EC2 instances, S3 buckets, and IAM. Now, it's important to say, with GuardDuty, you don't actually need to configure these log sources. GuardDuty will do this natively for you. So if you were using a partner tool or a third-party tool to do threat detection, you would be enabling the log sources. But in this particular scenario, GuardDuty does that natively for you. It extracts fields from the log files. They're encrypted in transit. It does this for profiling and then discards the logs. And so GuardDuty is a machine learning service that does threat intelligence and anomaly detection, identifying unwanted behavior, unexpected activity in your AWS accounts. And it finds then various finding types related to Bitcoin mining, command and control server activity, unusual user behavior, and unusual traffic patterns. Now, a little bit like the log data, what can happen sometimes with these services is an awful lot of findings, a proliferation of findings. And so GuardDuty, in that scenario, gives you the opportunity to suppress findings, to filter findings, and to sort findings. So for example, a finding type might be marked as high because this is maybe an EC2 instance which has been compromised. Or maybe you have finding types marked as low, which is something unsuccessful. You can look at it at a later point, perhaps, something like a port scan. And so through our session today, for a lot of these services, we're going to look into the management console to see what it looks like. And if you look into the GuardDuty console, what you see are the finding types related to the resources, when the event occurred, and the count, and the account ID it's associated with. And if you see this particular finding type here, it's marked as high on the left-hand side. And so if we look into the finding type, what we see is information about the threat, and what we have here is an EC2 instance, which is querying a domain name that's associated with a command and control activity, with a known command and control activity. We've information about where that instance resides, what region, and the severity type, and then this particular GuardDuty finding will automatically trigger a malware scan. And the malware scan itself then comes up with a finding which is associated back to the GuardDuty finding. And what we have here is we have identified the root cause of the threat, which is a virus. So that's analyzing the AWS logs, but if we move then to the next layer, the next area of data, we're looking at the configuration of our resources. Therefore, for AWS Config, our data types are actually the resources themselves, the configuration states of the resources. When you enable AWS Config in your account, the config recorder records the configuration state of each resource, and this builds a configuration item. And this builds up an inventory of configuration state, and it allows AWS Config to evaluate the configuration states over time of your resources. So AWS Config does this using config rules, evaluating the configuration state of the resources over time. And using config rules, you can reflect your desired configuration state of a resource, maybe something you have committed to an auditor or regulator. And there are different types of config rules. There are AWS managed rules, which for many of our resources, which we recommend, or alternatively, maybe you want to write your own managed rule. And so you can use Guard, which is a policy as code language, or using Lambda functions. And then you can bring together these rules into a conformance pack. So this is a group of rules, of configurations of resources that reflects the desired configuration state of your prepared environments that maybe you have committed to a regulator or auditor. And the conformance pack then will also include automatic remediation so that you can start remediating a deviation if somebody with maybe a permissive policy goes and changes the configuration of a key resource, it can automatically be remediated. We're going to talk a little bit more about that later on. And these rules are triggered based on changes in the configuration states of your resources. So if we look into AWS Config in the console, you can see it from two particular views, one from the resources or one from the rules themselves. And what we see here is a view of resources. We're filtering for security groups, and we see that we have a series of security groups that have found to be non-compliant. If we go into one of these non-compliant findings, we can actually see a per second deviation, which is incredibly powerful if we've experienced a threat in our environment, if we've experienced an incident in our environment, to be able to identify the second that the configuration of a resource has changed, and to automatically trigger the remediation on that second as well. Now, you can approach this from a resource perspective, or alternatively, maybe you want to approach it from a rules perspective, that you have set rules for your environment, that you've committed to an auditor or a regulator, and you want to identify what resources are deviating from these rules and when. And so if we look at a rule, this is an AWS managed rule around KMS key rotation, and we see that we have 4 non-compliant resources. And if we click into that, what we'll see are key IDs associated to the non-compliant resources, where we can then automate our response to. It might be, for example, re-encrypting the data with a new key. And finally, then, we have Amazon Inspector. We're moving into the third layer of data, which is our instances and our container registries. And Amazon Inspector is an automated vulnerability management service that continuously scans your AWS workloads for software vulnerabilities and unintended network exposure. It does this in near real time using 50 intelligence sources. And based on the network exposure, it comes up with a contextualized risk-based score. These scans happen continuously and have next to no impact on the performance of your fleet. So this happens automatically and continuously and runs across those prepared environments that we did in the earlier stage of the cycle. So here we see inspectors scanning 100% of the accounts, and it has identified 16% of the instances, four instances, where we have found critical findings. We see that, we've scanned 4 instances and we have found 21 critical findings. But we see that there are 0 critical findings when it comes to network exposure. There's also a history of scans that have taken place across our environments as well. If we go into this, we find out more information related to one of the instances where we have experienced our problems. And we see it's a CVE, a Red Hat CVE, and we have suggested remediation action. Inspector also gives us a highly contextualized risk score. This actually varies from the NVD score, the CVSS NVD industry score. And the reason for that is because of the deviation. The reason for that is because we saw on the previous screen that this instance wasn't reachable outside of the network. There were 0 network reachability scores. And so as a result, the suggested risk score from Inspector is slightly lower than the NVD score. And based on that, you can automate your response or carry out a manual response at a later stage. So, onto containment, collection, and analysis.
All right, thank you very much, Margot. Maybe just one thing to mention, because this is the way it is on reInvent. There's just another support for Lambda coming expected these days when we're launching new things, right? Just to mention that, though we didn't know that when we are creating the slides. All right, let's take a look to the next phases, multiple of them. So we're taking the collection, containment, and analysis phases and put it into one chapter, because this is basically where we're seeing quite a lot of iterations in that. So we'll talk through those 3 things together, but still starting with what we called triage and collection. And let's take a look on what have we seen so far in the detection phase. So typically, as Margot showed us, we have this whole raw data, the logs, the inventory data, so all the stuff which is basically information, which is not basically weighted measures and so on and so far. And then we have this area check, detect, and measure. We talked about 3 of the services from AWS. There are more security services falling into that pillar, but there's also the very likelihood that there's quite a lot of third-party services in that area. So what we're seeing with customers here is then typically also this notion of having a security incident and event management system running, right? And this is what people are using in order to put all the things together and do the analysis, if they do so, right? Some people do, some don't. But typically what happened is there is quite a lot of raw data going into those systems, and typically they're also putting in the findings data into that system. And this is completely fine to do so, but we'll have to keep in mind the cloud produces quite a lot of data, right? And it could be quite difficult and sometimes even expensive to do that and put all those things into a SIEM solution. So what we want to take a look is an alternative or an additional approach, and we want to do that in introducing what Security Hub can do in that purpose. So let's take a quick look what Security Hub is and how it works, right? So we're having these 2 pillars already, check, detect, and measure. We will see in a minute there is some functionality of Security Hub which falls into that pillar as well. But for the sake of easiness, we're having another pillar called consolidate and aggregate, right? And this is where Security Hub fits in as it receives data from all those AWS services, including the third-party services. And right now, I think we're having 15 AWS services natively integrated with Security Hub and more than 60 third-party services integrated with Security Hub, feeding all the data in order to consolidate and aggregate from different sources, right? But it's not only from different sources, it gets it from different accounts and it gets it from different regions. So Security Hub is really that single pane of glass view on all the findings coming from other systems which are doing the measurement, right? There is another functionality in Security Hub which we call the Cloud Security Posture Management. And this is basically a similar functionality what Margot told about in the conformance pack. And it's basically an orchestrated way of using services underneath in order to do that cloud posture management. So that's why I said, look, cloud posture management usually falls into that check, detect, measure, because it tells you if your estate is in compliance with your guidance, right? The other important thing here is we're keeping all the findings data into a common format. So this is the Amazon Security Findings format. You can build your own connector and feed it into that, but it makes our life much, much easier to have all the findings in a common format for further usage, either from an analysis phase, but also from an automated response phase. If you go to the Security Hub console just quickly, right? This is just giving a quick overview, Security Hub summary dashboard, and here you can see this is how we are compliant to our posture management components, right? So you see there are best practices from Center of Internet Security, there's also AWS Foundations, and there's a number of checks and rules behind the scenes which are basically measured for compliance. On the right-hand side, you see the resources with the most failed security checks, and you can tailor those, what we called inside, visually, but you can also put in rules in order to act and forward those things. Important to mention here, that's why I said their Security Hub is one of those services which is not only working for multi-account, it's also going cross-region. So really you get all your data into one place. In case something happens in a region which you're not using that often, right? You still have a single place where you look into that data. It's really important to keep in mind. If you go one step further, and let's say we go into the findings area here, and here we basically have filtered for a GuardDuty finding. So this is basically a finding coming from GuardDuty. It's showing up in Security Hub. We'll still be able to go through all of the details, right? So what is the finding, what are the instances, which subnets, and so on and so forth. And this is, important because we need to have this kind of information in the containment phase, right? And yes, you can get it directly from GuardDuty, or you can get it from Security Hub. And Security Hub, you just get it all in one place, cross regions, cross account. So that's basically the same kind of information because the source in this case is definitely GuardDuty. So let's take a look on the next step here. And this is basically the continuous containment in the cloud. And this is something, we're not talking about specific services. We're more talking about how you can leverage functionality of different services in order to help you. And I want to start on the left-hand side with the network isolation. And I'm just put it in a couple of logos, right? You see, you have our virtual private cloud, you have security groups, you have network ACL, you have network firewall. So these are all components which can help you to isolate your machines from the network. You need to make yourself aware that you're doing it on different levels, right? A security group can isolate things on the host base, right? A network ACL does it on a subnet base. You can use routing rules or a network file doing it on a VPC base. You have to keep in mind that it might have a side effect for other resources depending on where you're doing that network isolation, right? So it's important that we're giving you methods and tools and services which helps you to do the network isolation, but make yourself familiar in which level you do it and basically which kind of side effect you would have it, right? If you probably cut off a complete VPC, right? Well, maybe other machines in that VPC are not able to communicate anymore. So why is network isolation here also important? In the case of an incident and you want to step into a forensic process, you might not want to shut down the machine immediately. You might want to capture memory data or other things in your forensic process. So making a snapshot and put it up in a forensic environment might not be the best idea first. First, capture whatever you can, but in order to prevent further harm, right, isolate the machine from the network. So it's really important that you think about that kind of process in the forensic stages, and network isolation helps you to do things without shutting down the machine. Right? The next one we already discussed, logical isolation. It's basically the place where you can do your forensic, right? Different accounts, different OUs, service control policies, all of the kind of things help you to build an environment where you can basically put your machines in order to go into deepness and do the forensic tasks. So we're using organizations and this kind of things to do that. And then the last one is basically the forensic automation. And we mentioned it also before. Things like systems manager helps you to basically to automate tasks. This could be doing run command. This could be executing forensic tools on your machines, but it could also basically go into things like EBS snapshot, where you're making a copy of your machine and storing it somewhere else, right? These are services and functionalities which helps you in order to put the stuff in a different place, where in the old days, you had to have even different hardware, right? Here, this can be also fully automated, right? And these things can help. But again, this is where the skill component comes into place. Your people need to be familiar with those things, but then they can really help in order to do this. Okay, if we go to the next one, if you want to do further analysis, so come now to the analysis phase, right? So we've seen that before, right? We have the raw data, we have the check, detect, and measure data, we have the aggregated findings, and then we're putting a layer in we call analysis here, right? And obviously here a theme has its place, right? You can have a theme solution over there, third party, build your own, and so on and so forth. But there's also services from us, right? And there's a fully managed service, we mentioned that, Amazon Detective, right? And there is Amazon OpenSearch, which is basically helping us in order to build a SIEM-like or analysis capabilities, right? And both are various things, and we want to take a look to those functionality. However, what we want to show here as well, very often you might want to start from an existing finding, right? So you already have a finding in either Security Hub or GuardDuty or any of the other services. You want to go up to this analysis tool and then go down to the source of it, right? Because you want to do further steps and further analysis, right? So from an existing finding, sometimes makes stuff much easier, right? However, you might also be sitting on top of this and you want to start from zero and still want to do targeted analysis, right? We don't want to search the needle in the haystack. We want to do it as dedicated or as targeted as possible. And we will take a look to two samples. The first one, as I said, will be Amazon Detective, but we're here in the Security Hub console first, right? And we're going back to the same kind of findings, the command and control server triggered by GuardDuty. But if you now take a look to the right-hand side, there is a little button which says Investigate with Detective, right? And if I push that button, it opens the detective console, right? So you'd say, well, is that rocket science? No, it's not, but it gives you quite a lot of benefits. The first thing is, it shows me the related findings, right? It shows me a time window around this finding, and you can narrow or widen this time window, right? But it gives you basically a scope around when did this GuardDuty finding happening. And then it gives you what we call entities. And you see there is IP addresses. This, by the way, is internal and external IP addresses, which have been involved alongside with this finding. There's also then activity in a certain account, right? In this case, there is not a lot of data in there, but that's good for us. So nobody used that key and compromised something. And then there's, for example, the machine information, right? And when you click onto this, and you could click on any of them, and it's screenshot here, right? You can go even further, and here you could probably look into network data, right? From that place, you could also look into API data, where for this exercise or for this sample, we're using network data. So we're seeing the net flow data around the time frame of the incidents. And you can see basically if I go for inbound traffic and click onto it, I even expand it so I can see which IP address over which ports have been communicating successful or not successfully into that incident. So this really helps you for the analysis, and it's also helping you for the post-incident component in order to dig deeper and look into this stuff. So it gives you context around, right? Detective sits on top of CloudRail, VPC Flowlog, and it's also working the same way as GuardDuty. You don't have to configure that resources. We do that for you, right? But keeping in mind, you can only have access from it from the detective and the GuardDuty perspective. You'll not be able to use that kind of log data from another place, right? But same thing, you don't have to configure the log data if you want to use detectives for the analysis. Keeping in mind, you have to turn off a detective at a certain point of time, and from this point onwards, we're keeping the data for you. You just can't do it afterwards. We're not looking backwards in the logs, right? It's important, right? If you turn on detective after an incident happened, not a good idea, right? Okay, let's use one other example, and in this case, I want to use, it's the same picture, by the way. I want to use the OpenSearch Service. And what we're having here is basically a solution built by our colleagues from Japan. So solution architect colleagues from us in Japan have built that based on an OpenSearch cluster, and they are basically using, well, a security data lake. We're using S3. I mean, today you've probably seen we announced another security data lake. This is still the native component. But this is now giving us visualizations on top of data. This solution supports quite a lot of sources, including raw data as well as findings data from Security Hub or GuardDuty, but it has VPC flow logs, directory service logs, and so on and so forth. But we're having here is CloudRail data, and you see the visualizations or the panels are reflecting a certain key performance indicator, right? So you see which kind of accounts, which regions. We added a geo map where we're seeing where the origin of the API call is. But we also have other panels here, and I want to highlight this one with the login fail count. So this is basically a panel with a filter behind of certain event type when a login failed to the console or otherwise, right? And the idea is here, right? If you click now onto this panel, it's filtering down through only this API entries in CloudTrail, and it shows us, well, it happened only in this one account. It could be happening in multiple accounts. In this case, it happened in one account. It's been in this region, and it's been from Germany. So it's likely me, by the way, right? So it's basically this kind of information, though, while this panel's helping us really to go closer and closer to the data, we then can take a look and see, well, what are the actual entries? So we're blanked that out, so you're not seeing anything here. But then if you open it, you see really the full stack of the information coming from CloudTrail. So this helps us really with the visualization to see, hey, something is going wrong, something is bad, and we can really drill down into that solution and really go into the details on what might have caused that, right? And this is just another example on using cloud-native services, in this case, not a fully managed service. So we'll see how that goes moving forward in order to do more detailed analysis at a later stage. All right, so now let's over to the last part. Back to you, Margot.
Thanks, Armin. So in the last part of the NIST lifecycle, we're going to look at remediation, recovery, and post-incident activity. And there are a lot of requirements and commonality across these phases, though interestingly, NIST calls out something that we need to be careful about. Now, as security people, we all love order and structure and patterns, so to ensure that you're all still with me, I've thrown in a completely different type of slide. But in English, we have a proverb, and it says, don't shut the stable door after the horse has bolted. Meaning, in the critical proceeding phases and everything that we've just gone through and what we've seen in OpenSearch, if you're seeing an incident, this means that the unwanted behavior, the threat, is already in the process of occurring. And the need to respond is key. Automation becomes key, remediation becomes key. We don't want any delay, we don't want any lag. And so with cloud-native services, a key advantage is the speed and the automation and the repair of our environments. But when we talk about what remains the same, the challenges that we face pretty much remain the same. We still have auditors and regulators, third parties that we maybe need to report to if we've experienced a breach or a threat or an incident. If we experience an incident, our end customers now have ways and tools and social media to communicate broadly about this incident. So we care about our customers, and our customers can in turn inform other customers. And we still need to know what happened at exactly what time. So our challenges remain the same in these phases. We saw in the last section, Armin went over this single pane view that the Security Hub gives us, this uniform finding. And from that, we can already start in the previous phases automating our response. So our automation journey can actually begin already. Using services like EventBridge, which is a serverless event bus that lets you receive, filter, transform, and route and deliver events to other services like the Simple Notification Service or Lambda, for example, to perform an automated action to repair your environment, or Systems Manager. But likewise, we can also communicate to third-party tools in our organization or indeed to the humans if that's necessary. So the automation can already begin iteratively in previous phases. Now, in the NIST lifecycle, there's an interesting call out in the documentation around remediation and recovery, and what we need to be careful about in remediation. If we think about our earlier stages, we identified an instance which had been compromised. It was calling a domain name associated with a known command and control server activity. What we want to do, first of all, there is eradicate the behavior, is repair the instance. We don't want to recover a damaged instance or unpatched instance to the wrong region, to another region or within our same region. We want to eradicate the behavior, first of all. So in NIST, they call out this idea of eradication and recovery being done in a phased approach to drive remediation. And there are various cloud-native services in both capabilities to support you. So for example, we're going to be looking at Systems Manager in the next couple of slides, but we already saw AWS Config, which will allow you put together conformance packs reflecting the desired configuration state of your resources and allowing you to remediate and repair the resources immediately. In recovery, we could be looking at something like AWS Code Development Kit, which allows you to describe your environments in code, like for example, Python or TypeScript, and restore your environments. So if we think back earlier on to this instance, which we had identified in GuardDuty and later on in Security Hub, and we want to look at remediating this instance, the first thing we need to do is to actually patch it and to repair it. And so this finding would have been identified in Security Hub and triggered a rule, or alternatively in Systems Manager, which is a collection of capabilities to help you manage your infrastructure and operational problems across your AWS environments and hybrid environments at scale. A patch or Systems Manager can be triggered via the Operations Center. And the Operations Center is a dashboard in Systems Manager, a central location to view, investigate, and resolve operational items. And so this instance could have triggered Systems Manager to trigger then the Patch Manager to patch the instances and maintain the compliance of those instances. And this can be done with instances in your prepared environments in AWS, in your hybrid environments on premises or edge environments. And so if we look into Systems Manager, first of all, what we see in the left-hand side is that Systems Manager is a collection of capabilities: operations management, application management, node management, and change management. And we see in this environment that it identified 4 instances that need to be patched. And we can see a history of scans that have already taken place. We can go into these instances and see deviation from compliance reports that we might be using, like SOC reports, for example. And we can trigger the patching of the instance. This can be done automatically by Systems Manager using triggered by Security Manager and a rule, or by the Operations Center, or done manually. And then we can choose to scan and install, reboot the instance if necessary, and using tagging, we can choose a fleet of instances, or one instance, or hybrid instances, or edge devices. And so this way, as a first step, what we can do is eradicate the behavior of that instance. Okay, we can patch that instance. This then means we can move on to the next step, which is maybe recovering the volume associated to that instance. And so if we look at a service like AWS Backup, AWS Backup is a fully managed policy-based backup service that makes it easy to centrally manage and automate the backup of data services across AWS. It supports 9 stateful services. It acts as a management layer across these services, and using a backup plan creates backups into the AWS intervals in your AWS accounts. And these backups are encrypted at rest. This can be scaled then across your AWS prepared environments using AWS organizations, and is integrated with identity access management to lock down on what resources are performing what actions under what conditions. And logging and notifications then done to SNS, CloudWatch, and CloudTrail. And then, once the backup has taken place, the environment can be automatically restored using services like CDK, Code Development Kit, third-party tools like Terraform, or for example, AWS CloudFormation. So if we think about earlier on, we have patched our instance, we have maybe looked at recovering the instance, but now we want to recover an associated volume. And one of the things AWS Backup gives us is cross-account and cross-region support. And it does this using cross-account management. So here we have our instance in region A and its associated volume. In this AWS account, we have the backup plan, which describes the life cycle of the backups and the vaults where the backup for this particular volume and instance will go. But then this account is associated to AWS organizations and is in an organizational unit where we have a backup policy. And the backup policy is such that this means that nobody can change the backup plan in the AWS account. And we can define that the backups for this instance and this volume can occur into a different AWS account into different regions. And this protects our environment against account compromise, our prepared environments from earlier on. So if we look at AWS Backup, first of all, we see we have this notion of a vault, and here we have a bronze vault in the EU central region, and we have a series of recovery points for our resources. What we see when we go into the backup plan is that we cannot change it. So this cannot be changed in this AWS account. If somebody wanted to carry out suspicious activity and amend the backup plan, they cannot do it within that account. They have to go into the AWS organizations. Then we can see the resource assignment, the resources that this backup plan applies to. And we see it's the volumes and the instance IDs. These are the protected resources that we're doing the backups on. So if we click then into the policy, we're actually then into AWS organizations. We have come out of AWS Backup, and only in this view can you see the policy. You need to have these rights, you need to have this assigned to you via IAM. And so if we look at the policy, we now see information as to where the backup from that backup plan will go. And we can define a different region or a different account here. And here we're sending it to EU Central. And this is the life cycle as well of the backups. And so if we want to then carry out our restore, so we have patched the instance, we have repaired it, but now we want to restore the associated volume. We can choose an instance or an associated volume to restore, and maybe it mightn't be the latest one. Maybe we need to choose an earlier one because a compromise occurred in our environment in the last 24 hours, and so we need to choose an earlier volume to restore. We can choose the volume to restore, and then we can define information related to the subnet, related to the VPC, and related to security groups that we want to deploy around the instance and volume. And so this brings us into the post-incident activity analysis. Here, essentially, what remains the same is one of the most important things that we need to do is to learn and improve from the previous stages. We have information coming in from containment, eradication, and automation, and from this we can improve on our incident response, we can improve on our KPIs, we can improve on our metrics. We do have services to support us here, like Systems Manager, as Armin previously mentioned, which has an incident management console view where you can define runbooks, automation, and do incident collaboration across teams. But an important part of this, the post-incident activity, is the iterative phase through the NIST lifecycle, where you can feed back to all of the phases, learnings related to the incident, and improve your activities. As well as that, in AWS, professional services and solution architectures have various teams to support you in activities in this phase.
All right, thanks, Margot. So let's probably go to the last slide of this. So as a summary and conclusion, I think what we wanted to show today is that there's quite a lot of cloud-native services which can help us in that overall lifecycle. That said, there's not only cloud-native services. There might be other services as well. But what we also wanted to show that we could cover the entire landscape, and especially how the cloud, with its flexibility and agility, can help to respond and recover quickly, right? We're seeing how cloud-native services supporting SIEM and analysis capabilities, and we want to highlight again, I mean, the feedback into the process is really, really important in order to get better for the next time. With that, we want to thank you, and as another post-incident activity, you might do us a favor and fill out the surveys for us to get better. Thank you very much.
Thank you.